Welcome to Pre-Calculus, Section 7.3. This chapter is on conics. This time we'll be discussing parabolas. So we're going to talk about the definition of a parabola in a geometric sense. We've already studied them as functions on the plane, but now we're going to talk about them more in a geometric sense. So this definition here says, let F be a point in the plane, so that means on your piece of paper, and let D be a line not containing F. So here's your point F, and here's your line D, both on this plain piece of paper. A parabola is the set of all points equidistant from F and D. So all of these points that lie on this graph of the parabola are going to have the property such that this distance here from the focal point to the xy point here is equal to this distance here from the xy point to this line D. And that'll be the case for any point that lies on the parabola. These two line segments are going to be the same length, no matter what point you have on the parabola, and that's what gives it this shape. So the point F is called the focus of the parabola, and the line D is called the directrix of the parabola. So let me just make a parallel to something we all know a lot about these days. What about those satellite dishes on people's roofs, on their houses? Those are collecting radio waves, and the shape of the dish is a parabola. So this thing that sticks out right here is where your focal point would be. So any of the waves, the radio waves that are collected by the satellite dish, let's say it hits right here, they hit right here, so the incoming waves, they're then focused and collected right there. So any wave that hits this dish is going to be collected, concentrated, right at that focal point here. And that's how they're used. They're used to collect the waves and focus them to the focal point here. Next, the focal length P of a parabola is the distance from the vertex to the focus, vertex to the focus. So we'll call the vertex V and the focus F. It is also the distance from the vertex to the directrix. So this line here is the directrix. So this particular parabola here has a vertex at the origin, the point 0, 0. So what this is saying is that this focal length P is this distance here. So in order to get the point that corresponds to the F, the focus, you go up by the distance P. So your coordinate pair would be x is 0, y is P. All right, and then because these two distances are the same, we would go down by the same distance P to land on where your directrix would cut through, and your directrix is always going to be perpendicular to the axis of symmetry of your parabola. So your axis of symmetry cuts right through your focal point and your vertex and is perpendicular to your directrix. So your focus is an ordered pair, your vertex is an ordered pair, and your directrix is a line, the equation of a line, so it will have an equals in it. Next, we'll talk about the focal diameter. Its other name is the latus rectum, which is a Latin word meaning side straight. That's its little translation in Latin. So we're going to say that the focus is the midpoint of the focal diameter. So here's the focus, here's the focal diameter, this is the midpoint. And then we're going to say that the directrix is parallel to the focal diameter. So here's the focal diameter parallel to the directrix. So we A lot of times we will use the focal diameter to find 2 points on the parabola, which are equidistant from the focus, so that we can use those 2 points to get an accurate graph, so we can get the width of the parabola plotted accurately. So we'll have these 2 points, and then we'll have the vertex, and we can draw an accurate graph. Next, we're going to talk about the standard equation of a vertical parabola. So what we mean by a vertical parabola is that it'll be an upward facing or a downward facing parabola. Downward facing would look like this. So our vertex is this point here, which is given the standard HK, H for your x coordinate, K for your y coordinate. So in your equation, this x here, this H is your x coordinate of your vertex. This K is the y coordinate of your vertex. And then we've got the distance P here to your focus. So this is your focus right here. So P is this distance, which is also the same distance to your directrix, which would be outside of your parabola. So make a note that the focus is always inside the dish and the directrix will always be outside the dish. So let's make a note that this is also P, and P is in your equation. So this down here, when P is greater than 0, that's one way of saying that if you have a positive sign in front here, you're facing upward. And if you have a negative sign in front there, then you're facing downward. And that's something we already know about the equations of parabolas when we study functions. Positive faces upward, negative faces downward. In conics, we also study what we call horizontal parabolas. A horizontal parabola is going to face either this way or it could face this way. So we still call the vertex HK, and in our standard equation for a sideways parabola or a horizontal parabola, you're going to see that the H is still with the X and the K is still with the Y, except now the squared has moved over to the Y terms and not to the X terms. So if we go back and look at the equation for the up-down parabola, the square is on the X and not on the Y. So that's the difference in the equation. But still, your coordinate pair for your vertex is still HK, where your H goes with the X's and your K goes with the Y's. Okay, so the P still has the same meaning. It's this distance here. And then if you draw in your directrix, same, this distance here. So this is your P. All right, and the other thing that's the same is your focus is always inside your dish, and your directrix is always outside of your dish. Okay, now as far as the sign goes, if you have a plus here, then you're facing in the positive X direction. If you have a minus here, then you're facing in the negative X direction. All right, let's do some work now with these equations and graphs. So this problem says, given the equation in standard form, we're going to find the vertex, the focus, and the directrix, and we're going to sketch a graph. So first I'm going to look at this equation here. I'm going to notice that it's squared on the y. So that means this is a y-squared parabola, and I'm going to call that a sideways parabola. I usually use sideways as opposed to, I say sideways or up-down, as opposed to horizontal and vertical, so you can get a better image in your mind of what we're dealing with. So a sideways parabola. Now we can get the H and the K from the equation we're given. So H goes with the X and K goes with the Y. So my vertex then, if I write out my vertex, would be opposite sign. So if I have a plus here, I'm going to say minus 3. And if I have a negative here, I'm going to say positive 2. So you have to remember that you're going to have the opposite sign going on, and that occurs because you've got negatives here in your standard form of the equation. So if you test it out, this is your x-coordinate at vertex. X minus negative 3 is x plus 3. Y minus 2, y minus 2. So that should match. So I put my vertex on the graph, and I'm going to say this is a sideways parabola. Now let's see which way it would point. To know that, you've got to look at whether you have a negative. So I have a negative here, so this is a sideways parabola that's going to point in this direction like this. All right, so that means my focus is going to be to the left of my vertex. All right, so now let's find our focal distance P right here. So this number 12 is going to be that 4P. So that means P must be 12 divided by 4, which is 3. So that's going to move. This is going to be my focal point, my focus. So vertex, focus. So in order for it to be opening this way, I know that since my focus is inside the dish, I'm going to put it to the left of my vertex, where this is my distance 3 right here. All right, so I can also go ahead and plot my directrix, which is going to be 3 in this direction. So it's going to correspond to the y-axis, actually, in this case. All right, so that's my directrix right there. I'll just abbreviate it, directrix. So the coordinate pair for my focus then, if I read the coordinates off my graph, are going to be negative 6 in the x, 2 in the y. All right, and then the equation for my directrix is going to be a vertical line, so that's an x equation, has to have an equals, so x is equal to 0 is my vertical line. Let's get 2 more dots using our focal diameter. So remember, our focal diameter is going to go through my focus, and it's going to be parallel to my directrix. So I'm going to get 2 more points along that line right there. And I know from my equation given that my focal distance, the length of my focal diameter, I should say, is equal to 12. So half of 12 is equal to 6. So let me just say FD for focal diameter. That's this number here, 12. So I can go up 6 and down 6 from my focus and get 2 more points. All right, so I put those 2 points on there. Now I can get an accurate graph. So my parabola is going to go through the vertex and through these 2 dots at the end of the focal diameter. All right, so that is our parabola. Okay, so looking at our next example here, I've got a squared on my x terms. So this would be the standard form of my equation. So when you have a square on the x terms, that's an upwards or downward facing parabola. So I have a positive here, so that's going to be an upwards facing parabola. So I'm just going to make a note of that. I know that my parabola is going to end up looking like this. So first I'm going to write my vertex. From my given equation, this is going to be where I get my h, and this is going to be where I get my k. So opposite sign, I'm going to have 1 and then negative 3. So I can put that on there, 1, negative 3. Here's my vertex here. All right, so then I go ahead and I look at my 4p number right here. So that says 4p is equal to 4. So that must mean p is equal to 4 divided by 4. P is equal to 1. So if my focus is inside the dish, that means I would draw my focus here. All right, so it's going to be up by 1. So the coordinates of my focus are going to be the coordinates of that red dot, which would be x is 1 and y is -2. All right, so then for the directrix, it's going to go in the other direction by that same amount, 1. So I'm going to draw it in here. So this is my directrix. So this time it's a horizontal line. So my directrix is going to have the equation y is equal to -4. So before we draw it in, let's get 2 more points on the focal diameter. So my focal diameter is 4. The length of my focal diameter is 4. So half of 4 is 2, of course. So starting at my focus, so here's my focus right here. I'm going to go 2 this way and 2 the other way. So I've got 2 more points here. Okay, so now I can draw in my upward facing parabola fairly accurately. So I drew it in there. So now we've done everything they asked for. Let's just go ahead and highlight our results. So we've got the vertex, we've got the focus, we've got the directrix, and we've got the graph. All right, our next example, it's the same set of instructions given a different equation here. So I've got an x squared parabola again, so this is either an up or a down facing parabola. So I look and see that I have a negative right here. So that tells me that my parabola is going to be facing downwards. So I do know that my focus is going to be inside the dish. All right, so let's get the vertex first. So the vertex, opposite sign, so opposite sign here and here. So it's going to be -2, 5. So I can put that on my graph. All right. Now I know that 4p is equal to 20. So that tells me that p is equal to 20 divided by 4, which is 5. So that tells me where to put my dot for my focus. I've got to go down 5. So that means my focus, if I look at the coordinates of that green dot, are -2, 0. All right, so now the directrix then is going to have to go in the other direction. So it's going to go off the graph a little bit here. So if I go 1, 2, 3, 4, 5, it'll be about right there. So let's go ahead and estimate that position. All right, so it's cutting through the graph at y is equal to 10. So that's my line, y is equal to 10. So that's our directrix. So I've got my vertex, I have my focus, and I have my directrix. The next thing we need is 2 more dots so that we can draw this thing in. So here's where the focal diameter comes in. Okay, so from my given equation, this focal diameter length is 20. So if I divide that in half, 1/2 of 20 is 10. So that means I'm going to go 10 to the left of my focus, parallel to my directrix. So let's get those 2 dots. So 10 to the left and 10 to the right. Then I should be able to draw in an accurate graph. All right, so I extended out my x-axis a little bit here. So starting at my focus, I'm going 10 to the left and I'm going 10 to the right. So now I have 3 dots, 1, 2, 3, and I can sketch in my graph. So there's my graph, and everything else is highlighted. So we finished this problem here. let's do one more like this to cover all of our potential ways that it can face. So this has a square on the y. So if you got a square on the y, that means you've got a sideways parabola. And I look at my sign here to see which way it's going. So this is a positive, so it's going to go in the positive x direction. So I know that my graph is going to be looking like this when I'm done here. So let's do the vertex first. So opposite sign. So opposite sign for the x would be 2. Opposite sign for the y would be 4. So my vertex is 2, 4. Let's plot that. Next we'll figure out our focus. So our focus is always going to be inside the dish, so we know which direction we're going to go to plot it. So looking at our 4p number, 4p is equal to 18. Remember, our 4p number is here. So 4p is equal to 18. So that looks like it's going to be a fraction. So p is equal to 18/4, which is equal to 9/2, which is equal to 4.5. So p is equal to 4.5. So let's figure out the coordinates of our focus now. So I plotted on 4.5 units to the right of my vertex. So that would take it to 2 plus 4.5, which is 6.5 in the x. You could either do this in fractions if you want, or decimal numbers. And then it would have the same y coordinate as the vertex, so that would be 4. So I have my vertex, and I have my focus. Let's get the directrix in now. So my directrix would go 4.5 units in the opposite direction. So I'm going to count 1, 2, 3, 4.5. So it's going to cut through there. So it's going to be outside the dish. So it's going to be a vertical line cutting through that dot here. This is my directrix. So if I write the equation for my directrix, it's a vertical line cutting through at x is equal to negative 2.5. We can see that. So the equation is x is equal to negative 2.5. So the last thing left to do is to figure out 2 more points on a parabola and draw a sketch. So we'll look at our focal diameter. So looking at our equation, the length of my focal diameter is 18. So that means I'm going to take half of 18, which is equal to 9. So I'm going to go up 9 and down 9 from my focus here. So I'm going to be off the graph a little bit here. So I plotted those 2 dots here, the ends of my focal diameter. So this is 9 here, and this is 9 here. So now I can draw in a sketch of my parabola. So that's roughly a pretty decent sketch of my parabola, and that takes care of this problem. So we're going to do a couple other types of problems on the second part of this lecture. So I hope you took good notes.